So we have rounded parentheses that have a meaning as algebraic grouping, and they have a meaning as introducing tuples. We have square brackets, which have the meaning of introducing lists, but not a meaning as algebraic grouping, but they have an alternative meaning as an indexing expression. So let's see what this means. This expression here, this is actually an operator applied to a string. So it's a unary operator. It says, give me the 11th element of this string. Now a string is a sequence, and every element of that string is a character. This is itself a string. So when I ask for the 11th element of the string, I will get back a string of length 1 that corresponds to the 11th character here. So let's see, which one is that? Okay, I claim the 11th character is the E. Oh, come on, damn it. And in fact, I get back a singleton string that's an E. Now, if you do a little counting on your own, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, it looks like the 11th character is the T. But Python thinks the 11th character is the E. Anybody know why? Yes? Because we start counting at 0, unlike the calendar and icon. Start counting at 0, so this is actually the 0th element, 0, 1, 2, 3, the space counts, 4, 5, 6, 7, 8, 9, 10, 11. You use the 11th character and I get back the E. So this is an indexing operation, indexing from 0. The brackets have therefore two meanings. They indicate a list, but they're also a unary operator on sequences. Now I can do the same thing with the tuple. I can ask, what is the length of this tuple? Notice the same function operates on all the sequence types. There are 3 elements in that list, that tuple. I can index the tuple. What is element 2 of that tuple? Well, element 2 of that tuple is the element that occupies the 3rd position in the tuple. Position 0, 1, 2, I get back a 3. Notice that the type of the return value here is whatever that object is. What about length of the empty list? What's this likely to return? Absolutely. You get a 0 back. What about this weird expression? What is this? So, I've got 2 brackets, but they don't follow a sequence type, so this must be a list. In fact, it looks a lot like the empty list. So those first 2 brackets are the empty list, and then this thing, these 2 brackets are not a list because they follow a sequence. So it's a unary operator asking for the 0th element of that list. What does that give me? It gives me an error. Why? Because the length of this list here, we know, is 0, and the 0th element of an empty list is an error. The 0th element corresponds to the first element. If the list has 0 elements in it, there is no first element, and you will get an error. So what this slide shows you is, just to review, that the square brackets, which we know introduce lists, when abutted to the end of a sequence type, contain an indexing expression which is an integer that returns whatever element is in that integer version of that integer position of that sequence, starting counting at 0, and returning something of the type of whatever the object is in that 11th place. For a string, the object return will always be of type string, because the string's elements are all uniform. For a tuple or a list, the type of the object return depends on what's occupying that slot in that tuple or list. So, those of you who've written code in Java, what does this look like? Looks very much like some sort of array object, right? Where you have an array and you can index the element of the array by counting starting at 0. And you'd be almost right. It's a lot like an array object. But it actually has some other features that we'll see in a minute that extend the syntax of indexing into a sequence type. So for now, you've only seen me pluck out one element of a sequence type, but we actually do some kind of magical things by plucking out ranges of elements and subsequences of that sequence as well. So let's review what we saw today. Introduce lists. I reminded you that singleton lists are not like singleton tuples. I reminded you why, because this is algebraic grouping, and this is a list, and this is a tuple. I also introduced the indexing expression, which is the second meaning of the square list. And then we repeated together the CS 101 mantra, which is lists are mutable, strings and tuples are immutable. I just saw this. I don't know why I'm seeing the same slide. I think I made a mistake here. Okay. Let's continue our discussion of indexing and show you how this simple notion of extracting an element of a list or tuple or string can be extended in Python over what you expect from other languages with arrays. So first of all, in Python, I can use a negative number as an index. And what this means in Python is that instead of numbering 0, 1, 2, 3, I start counting from the end of the sequence. So 1, minus 1, minus 2, the minus second element is going to be 5. Now you'll notice that when I started counting from the end of the sequence, I started counting with 1 and not with 0. Why is that? Why do I start counting from 0 from the left side but with 1 from the right side? This again.
Because 0 can only be in one place.
There's only one 0, guys, right? There's no negative 0. There's only one 0. If I had a 0 from the right and a 0 from the left, I would have to have 0 and negative 0 mean two different things. And that would really screw up your counting system. So when I count from the beginning, it's 0 indexed. When I count minus 1, so this is a 0th element, minus 1, minus 2, minus 3, minus 4. Now this can be incredibly handy because it's easy now to ask, what is the last element of the sequence? I would just give you the sequence and say minus 1 in the index place and I get the last element of the sequence. Another cool thing is that I can extend this sequencing, this indexing expression to be just not one number but two numbers separated by a colon. And what that means in Python is that I'm asking you now not to return one element of this sequence, but return a subsequence of elements in this sequence. So let's see how this works. So the way to think about this expression here is that I want to return a subsequence of this sequence starting with element 1 up to but not including element minus 2. Now we're not including this y in a second. So let's take a look at this. I have element 0, element 1. So 3 would be my first element. This is element minus 1, element minus 2. So I'm really just going to return the subsequence starting and ending with element 3. That looks a lot like returning one element, but it's not one element. It's a subsequence of length 1. So notice the difference. When I return one element, I get the number that is occupying that spot. Whatever object is there, that's what I get. When I ask for a subsequence, I get a list containing that object. It stands to reason because if I had asked for a subsequence of more than 1, say I might have had 3, 5. If this had been 1 up to but not including minus 1, I would have had the list 3, 5. So that colon says return a range of elements from that sequence. Same thing works with strings. From 4, 0, 1, 2, 3, 4, that's the blank, up to but not including 8, 5, 6, 7, 8. So I'm going to return the subsequence, space is space. Now let's say a word about the Hinkley numbering scheme. It always includes the first element in the subsequence, but it goes up to but not including the second element. Now in future, it seems odd that we would not include that second element. You'd be sort of inclusive on the left, on the lower side, but not inclusive on the upper side. The reason is that the sequence I return, the subsequence I return, if I interpret it this way, will be exactly 8 minus 4 in length. If I were to include before 3, 8 inclusive, it would have been 8 minus 4 plus 1, and we would have to remember that offset. So much easier to remember that ranges are inclusive of the first number, but not inclusive of the second number. That way, way, you can do index arithmetic to figure out how long the subsequence is expected to be. A minus 4 is 4, I get back 4 characters. What about if I give the initial value, but I don't put a value at the end? Well, that's, again, syntactic sugar. What this does is it says, return the subsequence starting at element 4 inclusive and going all the way to the end of the string. Now, what number would I have needed to put here otherwise? Well, if I would put here the length of the string, remember this is a 14-element list. 1, 2, 3, 4, 5. It's a 14-element string. If I had put as the second index the length of that string, then I would have gone starting at 4 up to but not including the length of that string index. So the same logic applies here. The string has 14 characters. The length is 14, but the last value is at index position 13 because we started counting at 0. So going from 4 up to the length of that object is inclusive of the first element, but not inclusive of that last index because no such index exists. So all this is done uniformly and consistently. An index sequence is inclusive of the first value, but not inclusive of the last value. And with index this way returns a subsequence of the sequence object it's attached to that is exactly n minus beginning elements long. I can do a similar kind of syntactic sugar here by giving the end element and not the beginning element, which defaults then to 0. And the string from 0 to 8 is simply the first 8 characters of the string. And there you have it. So, strings are immutable, tuples are immutable. This is an ordered sequence of characters, that is strings of length 1. This is an immutable ordered sequence of arbitrary items, including anything else you want. Lists are analogous to tuples, but they're mutable. And all sequence types share indexing and length operations. So here's a sample list. This is index position 0 to index position length minus 1. The length is 10, so the last position is index 9. And if I start counting from the right-hand side, I start with 1, so minus 1 through minus 10. This lets me index all of these values. Right, so remember this picture, and remember that lists are mutable and strings and tuples are immutable. These things will serve you well as you go through your sequence types. So let's do some examples. We still have time here? Yes. So I'm just going to type some expressions to the Python readout print loop. Let's work through them together and see if we're right. So this is a string, which is a sequence type of 1, 2, 3, 4, 5, 6 elements. I'm asking for the third element of that string. What do I get back? The string of length 1, what's the letter? Oh, 0, 1, 2, 3. So I get back the string of length 1, which is an O. The plus sign on strings is concatenation. So I'm going to splice that to forge, which is a string sequence type of 1, 2, 3, 4, 5 elements, labeled from 0 to 4. And I want, in the index expression, I want one element, which is the result of integer divide 5 by 2. Wow, so in this indexing expression, you can do arbitrary math. As long as you get an integer back that is between 0 and the length of that value of that sequence, you're good. Here, this is the length of forge. 5 integer divide 2 is what? It's 2. 0, 1, 2 is R. So I get back a string of length 0 of length 1, which is an O, a string of length 1, which is an OR, and I get a new string OR. Now I want you to know this. Integer division is useful for finding, if I start with the length of the sequence object, integer divided by 2, for an odd length string, or an odd length sequence, I will get back the central element. For an even length sequence, I'll get back the element just before the center dividing line. So these are handy index operations to extract parts of the sequence that matter to you. So remember, oftentimes in index expressions, you will see integer divisions just to get that kind of thing to work. It's another expression. So what is this object here? What is this? It's a tuple of 0, 1, 2, 3 elements. Each element is a string, which is also sequence type, but each string is at length 1. So this tuple is length 3, and each element is a string of length 1. I'm going to concatenate the tuple with this thing, which is a tuple of length 2. And then there's this weird stuff. I'm going to multiply this tuple by some integer, because this is an integer. I know length returns an integer. So tuples can be multiplied like strings. So let's see what this integer turns out to be. This is a list of length 3, 0, 1, 2. And I want 0 up to, but not including 2, 0, 1, 2. So this expression here gives me a list of 2 elements. The length of that list is 2. I'm going to multiply the tuple by 2, and I'm going to splice it to a tuple by 3. And what I get back is the first 3 characters from this tuple multiplied by 2 gives me that tuple, and I splice them together to get a 7-element result. Now, nobody would write code like this, right? But the point is, you need to sort of really assimilate the rules for understanding index expressions so that these things become facile to you, right? So you should be able to get an expression like this and without panicking figure out, well, what is this thing? And what does that do to it? And what is the length of that list? And when I have an integer times a sequence type, what does that do? And when I have 2 sequence types with a plus sign, what does that do? You should be able to reason through this and come up with the value of that expression without having to resort to typing it to Python, which is a way to check your work. What about here? This thing is a tuple of length 4, 0, 1, 2, 3. I want to start at number minus 3, minus 1, minus. So I want to start with this false. I want to go up to and include, but not including 3, 0, 1, 2, 3. So I'm going to extract the center 2 elements of that tuple and return a new tuple with just those 2 elements in it. Okay. This I know in is a logical expression on sequences. I want to see if P is in this string. Well, certainly P is in once upon a time. It's right there. But actually, the string here is not the string I'm looking at. I'm looking at the string after I do all this stuff to it. And what's all this stuff? Well, the first thing I'm going to do is I'm going to extract the subsequence from 3 up to but not including 10. That'll give me a substring of this. And then on that substring, I'm going to extract a substring from minus 6 up to but not including 6. And on whatever that returns, I'm going to extract the first 2 characters. So I'm going to have to apply each of these indexing operations one after the other to this string to figure out if that P is in whatever remains. All right? The answer is true. How? Well, here we go. Once upon a time, from 3 to 11, 0, 1, 2, 3. So start on the E, 4, 5, 6, 7, 8, 9, 10. So between E and A. So that's a string. Now I'm going to go from minus 6 to 6. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. So start on the U, up to but not including 6. 0, 1, 2, 3, 4, 5, 6. So I'm going to have the word upon. And then I'm going to take the first 2 characters of upon, 0, 1, up to but not including 2. So my real expression here is P in up. And the answer is true, and that's why I get it. Okay, I'm going to stop here. We've covered strings, lists, and tuples. You have a lot more information in your book on other operators on those strings, lists, and tuples. On Wednesday, we're going to cover ranges, which are also sequence types, although a little bit different. And then we'll be done with sequence type when we go on to mapping types. We're getting through the first part of the class pretty quickly. So don't forget Lab 1 tomorrow. On Wednesday, question of day 2 will be released right after class. And on Friday, question of day 3 will be released right after class for the weekend. All right, have a good day.